So proteins have different jobs and they have unique shapes. The proteins inside you are unique to you. All right. Now, these are what we call antigens. Some antigens belong to you, like your blood group. If you're blood group A, you have a protein in your blood and the cell membrane, and we call it A because, well, it's easy to call it A. It is an antigen that belongs to you. If you get an antigen in your system that doesn't belong to you, it can be on a virus, it can be on a bacteria. These are called foreign antigens. However, we're going to keep it simple. When I was young, I was a little bit mischievous. I used to go around the world, get myself into all sorts of tricky situations. I've been in the middle of the Sahara Desert. I've been in tropical rainforest. I've been up a mountain. Full enough, I came back from a mountain in the Sierra Nevada over Easter. So I've done some crazy things. Now, one thing I want to talk to you about is one of the first poisons I ever came across. And it was during my studies at uni, and it's alpha bungarotoxin. It is a snake venom. It is particularly from the black mamba. It is a poisonous snake. So I know about snake bites because if I get bitten by a snake, I need to know what to be able to do. Now, alpha bungarotoxin, as I said, is a venom, a snake venom. It's actually a protein, all right? And it is if when a snake bites you, when a black mamba bites you and injects you with alpha bungarotoxin, it is a foreign antigen, meaning it doesn't belong in your system. So I'm going to draw it. So this triangle here, oh, I did a green triangle. I'm going to do that green triangle. This is a green triangle. Okay, this green triangle, so here's my blood vessel, here's a red blood cell, and this green triangle is alpha bungarotoxin. The little protein, I've drawn it like a triangle because it's a specific shape. If your body had time, it would go, oh, look, something does not belong in me, and it would create an antibody. An antibody is a protein your body makes, and you've got lots of them, and they're a specific shape. So this antibody fits alpha bungarotoxin. So you can imagine alpha bungarotoxin wants to kill you. However, an antibody comes along, goes ha ha ha, and sticks to it. And this is like a sticky weapon. And it will bind to alpha bungarotoxin. The alpha bungarotoxin cannot bind to any part of you and kill you. And you're like, yeah, you're all right. The problem is to make this sticky weapon, to make this antibody, it takes 4 days. All right? If you're bitten by the black mamba, you got a couple of hours. You haven't got 4 days. So what you can do is you can make a monoclonal antibody. Monoclonal antibody. And the monoclonal antibody, you've seen it in movies and stuff, is called antivenom. Now, I've been a little bit adventurous since I was a young man, since I was 18 and I left home and I went to university. So word of advice, when you grow up, and it's not very long, it's about 5 years, and you decide to do something adventurous, if you get bitten by something, take a picture of it. Because every snake, every scorpion produces its own venom. So what you do is you go, oh, it bit me. Do a selfie with a snake. Go to the hospital and say, this snake bit me. And they will go to the fridge, take out a little bottle, and inject you with antivenom. Antivenom is nothing more than these sticky little antibodies whose shape fits that specific venom. Now, begins the fun stuff. How do you make monoclonal antibodies? Well, anyway, before I go on to that, your task today is text extraction. This is how you actually make it. So you're going to read through this, the different uses, and fill the sheet in here. However, what I'm going to do is I'm going to teach you how I make it, or how we actually make these. Oh dear. All right, so where's it gone? I just put it on here. It's disappeared. Ah, there it is. So I'm just going to what you do is you don't have time to make antibodies in your system because you've been bitten, you're at 20 minutes. So what you do is you take little cute bunny rabbit. Hello, bunny rabbit. I shall get you a picture of bunny rabbit, but not yet. So you take little bunny rabbit and go, hello, bunny rabbit. and you inject a little bit of the venom. Not too much to kill the rabbit, but enough so it has an immune response. So its white blood cells go, oi, dude, you don't belong in me, and start making antibodies. So you inject it and you wait and watch. And the rabbit, for a few weeks, doesn't feel so good. As its body starts making lots and lots of antibodies. You are working with the rabbit, so you tell rabbit, it's okay, sweetheart, you can be fine. Don't worry about anything. I didn't give you too much. So the little cute bunny rabbit makes lots and lots of, they're called B lymphocytes, white blood cells that produces antibodies. You go, oh, well done, little cutie rabbit. You've done so well. You've got lots of white blood cells inside you, and I want them. Actually, it's not in the blood, it's mostly in the spleen. It's time to liberate the white blood cells. So you say to your cute rabbit, thank you so much for helping me. And with a nice, swift whoosh, goodbye, Fluffy. You cut out the spleen carefully. Make sure it's fresh, so the cells in the spleen aren't dead yet. So you cut out the little fluffy rabbit's spleen. It's so pretty. So you take the B cells, you then mix it with myeloma cancer cells. Cancer cells never die and always replicate. So you take these white blood cells, these B lymphocytes that were producing the antibody, you fuse it with a cancer cell, and you produce a hybridoma. It is literally a zombie B cell that will never stop dividing and it will never die. And you're producing lots and lots of alpha gal antibodies. And you pick the best ones, the best hybridomas that are producing lots and lots of antibodies. And you give them lots of food and clone them. So, the sacrifice. You then bottle those antibodies so you can inject them into somebody who's bitten. And that is the job the nice, pretty, fluffy rabbit did. Now, just in case you're uncertain, yeah, you see little cutie rabbit and we're going to do an operation on it? Yeah, no, we're not. I want to explain. All right. Yeah, it's not. It's myxomatosis. It's disgusting, Lani. I hate that. So, anywho, that's how you make monoclonal antibodies. I'm going to stop recording.